In this video, I'm going to show you how I was able to revive the dead battery in my Sony Vaio UX little handheld PC, but this technique should work for any laptop battery. Now, a little background, pretty much any lithium-ion laptop battery made from the 2010s and earlier, chances are it's not going to work anymore. I actually find that nickel metal hydride or NiCad batteries that are even older tend to be more likely to still be working. So I'd kind of just accepted that these older laptops, you just need to use them plugged into the wall. But this little Sony Vaio UX, being more of a handheld, I really wanted to have a working battery, even if it just held charge for a little while. Now, it's pretty much impossible to get new batteries for these. The OEM batteries are all out of stock, and I would question any new old stock batteries. Even the kind of knockoff manufacturer batteries are all out of stock. Used batteries would be questionable, so pretty much the only shot is to try to repair it yourself. So my Vaio UX came with two batteries, a standard battery, which is a 2-cell battery that fits flush in the unit, and I also had the 4-cell extended battery that kind of sticks out to the side. Both of my batteries were completely dead. When I had them plugged into my Vaio, Windows didn't even register that there was a battery plugged into the unit. First, I tried to repair the smaller battery. I opened it up, I checked the voltages on the cells, and they were completely flat, 0 volts. And usually when a lithium battery is completely dead, it can't be brought back. So I got some replacement 18650 cells. I soldered them in. But when I tested it out, Windows now saw a battery. It saw a capacity. It was even able to correctly read the voltage. But it didn't charge them. And if I unplugged the power, the laptop would completely shut off, so I wasn't actually putting out any voltage. My assumption here is the little controller inside the battery management system, or BMS, had set a flag when the battery got to a critical level that basically disabled itself. Even though I replaced the cells with new ones, it was still locked out. I saw there were trick videos on how to reset your BMS by kind of jumpering different wires, but it seemed kind of sketchy. I think the only true way to actually reset it is to use software that reads the EEPROM, reads the chips, and lets you change the parameters to unlock the battery again. So in the end, I gave up on this first battery for now. Just kind of pulled the guts out, just using the plastic shell as a placeholder for display. So then I moved on to my extended battery pack, and after I disassembled it and checked it, I saw that the batteries actually still had a little bit of charge left in them. So this gave me hope that if I could bring up the voltage level enough that the laptop would start recognizing it again, then I could charge it up fully, have a working battery. It'd be a lot less work than replacing the cells, which in my case, for this specific battery, did work. That's what I'm going to show you the entire process in the remainder of this video. And now a disclaimer, I'm a novice when it comes to electronics, and this is the first time I've ever tried to repair a battery. I did a lot of research beforehand from different sources, but working with lithium batteries can be dangerous and a fire hazard if you're not careful. I was particularly concerned on these really small packs that it's common that one of the cells will actually be completely dead, and kind of charging it may overcharge the other cells to try to compensate to bring it back to the previous levels. But with that introduction out of the way, let me show you how I was able to revive my battery. So here I'm starting to figure out how I can open up this battery. Now, some batteries are held together with a bunch of strong glue and clips. Some batteries I think are sonically welded, and you almost need to use a Dremel cutting wheel and an X-Acto knife to open them up. I tried to use a couple different pry tools to get inside. In the end, I went with this metal spudger, which was the only thing that had a good enough edge and was strong enough. Normally I want to use a plastic spudger tool when I'm prying on plastics to avoid kind of marring up the edges, scraping them up. Later on, I'll use some plastic cards to kind of wedge things open as I'm going along. You can see I'm starting out prying on the side opposite from the battery connector. I think starting out on the side with the connector is a little more sketchy because this takes a lot of force. And on that side, the circuit board's right underneath there, so you risk kind of slipping through and damaging the board or possibly shorting something. On the smaller 2-cell battery I did before this, it's actually a lot easier because the seam on the back was right along the edge. So it was easy to get underneath it, pry it up, and then I was able to use my fingers and kind of pull the top off within a couple minutes. But this seam is kind of right in the middle on a rounded battery. and it was too hard to get into. So eventually I do need to go in from the other side with the power connector. So basically I spend the next 15 minutes trying to open up this battery. I've left the whole thing in just in case anyone finds my struggles useful. Otherwise you can jump ahead to about the 13.5-minute mark or check out the timestamps. So now that we finally have access to the battery, first I'm going to see how much voltage is actually left in this battery. So generally you're going to have your batteries all connected together in series and parallel through little metal strips welded to the ends. And they'll kind of combine together as a positive and negative going into the circuit board. To kind of clean off some glue here, I'm testing it at 2 contacts. 1.36 volts. Now I swapped the probes to demonstrate that if you hook them up backwards, it'll show a negative voltage if you have the positive on the negative end of the battery. Now a question may be, the battery itself has 2 terminals on the outside labeled positive and negative. Like, why can't we charge through those? For me, those pins don't actually read any voltage. I don't think those pins are a direct pass-through to the battery. I think the controller decides when to put voltage through. There's kind of a detect pin so it knows if it's plugged in the laptop. In my checking, it may be possible to connect some of the lines together with a resistor to fake it out to thinking it's plugged in, but all batteries are kind of wired different, so this was kind of the easier method. But if you do see voltage on those 2 pins, it may be possible to just charge through them without actually opening up the battery like this and going directly to the cells. I suspect that's only possible though on really early lithium batteries. Now I'm going to just do a quick confirmation with the multimeter to make sure I have good contacts there with the clips. So my initial attempt to charge here, I'm using a smart battery charger that can charge all different kinds of batteries. We can't do a balanced charge with this setup, so I'm going to switch it to just a regular charge. And we have 2 cells in series, or 7.4 volts. Most laptops will be 3 cells, 10.8 volts. Should show that on the outside of the case. Going at 0.5 amp. We start charging and get an error. So just like when it was plugged into the laptop, the voltage is so low in this battery that the charger doesn't even see it as a battery. So now it's time for plan B. I'm going to plug this battery pack directly into my variable power supply, setting it for 7.4 volts, starting out really low at just 0.1 amps. So here you can see it's starting to charge pretty quick at first. I'll speed it up. So at this point I'd gotten it up to 5 volts. Tried it on my smart charger again. Still didn't see the batteries. So I'm going back to my variable power supply, but this time doing it at 0.2 amps. I'll speed it up again. So after getting it up to 6.75 volts, I switch back to my smart power supply, and this time it detects the batteries and it starts charging. I feel a little safer using the smart charger to get the battery up to its baseline, which is 7.4 volts for this 2-cell pack, since it automatically adjusts the output amperage. And now that I've charged my pack up to the baseline, which is basically where the battery should be when it's empty, I'm going to fully charge it up in the laptop itself. I believe this way you should be able to do a proper balanced charge, where the little controller inside the pack is able to individually charge each cell, since they may each be at different voltage levels or capacity levels. So now in Windows, first we're going to check out the power options, and we can see we have 2% battery plugged in and charging. Well, it's not a guarantee because my other battery also said it was plugged in and charging, but didn't actually take a charge. There are a couple of tools you can use to get more detailed battery information. Use hardware info. I'm going to use hardware monitor here. And here at the bottom, we can see our details. We can see the voltage, which is 7.7 volts. Now, an empty battery is about 3.7 volts per cell, 4.2 volts fully charged. So this should read about 8.2 volts when full. We can see our capacity and our current capacity. Right now we got 980 milliwatts. We'll watch it for a moment. And 1030 milliwatts. So the battery is now taking a charge. Another thing to notice here is the wear level is at 0%. That's because it says the design capacity and the full charge capacity are the same. Now batteries degrade over time. They lose their maximum capacity. This says 0%. I think something must have gotten reset because this definitely doesn't have the full life it would have as a brand new battery. And we'll see that in a moment when I jump to the end of the charge. So after a couple hours on this first charge, it stopped at 60% charge level, about 23,000 milliwatts. And now for the moment of truth, unplugging the power adapter and seeing if it runs off battery. See here, running off battery, initial estimate by Windows, over 2 hours left. So in conclusion, I let the laptop continue to run until it dropped down to 5%. So it didn't randomly shut off early. It took about an hour and 15 minutes. I charged it back up. Again, it stopped at about 60%, 23,000 milliamps. I unplugged it, let it run down to 5%. And this time it ran for about 2 hours. I plugged it back into charge again. It filled back up to 23,000 milliamps just like before, but this time it actually said 100%. The wear level still says 0, but it kind of seems like this is the true level, and maybe the controller is kind of learning that this is where the battery truly is. So overall, I'm pretty happy how this came out. This is kind of an unobtainable battery, and I went from a battery that wasn't even recognized by the laptop to a battery that runs successfully for about 2 hours plus. If anyone has any suggestions on anything I could have done better or differently, please let me know in the comments. I do worry about what would have happened if a cell would have been completely gone and unchargeable. But that's it. Thanks for watching.